Okay, in this podcast I'm going to talk about scientific notation, something that you need to be comfortable using, going back and forth from scientific to standard notation. Okay, so here's lots of scientific measurements, values that all have these exponents here, and those exponents represent scientific notation. And the reason we need to use scientific notation is that in science we deal with some huge, really large numbers. Like this number we're going to use a lot. This is the number of atoms or particles that are in something called a mole. And we also deal with tiny numbers. If we want to know the mass of an electron, the standard units are kilograms, and this is how many kilograms we'd have. Tiny. So it's not real practical dealing with these measurements with all these zeros. So we shortcut it. So scientific notation is just a method of representing very large numbers in a standard format. This m, sometimes called the coefficient, is a number between 1 and 10, okay, and n is an integer. So let's say we have this number. We want to start by inserting what is understood to be the decimal point. So if you look at this number, the decimal point would be at the very end. Okay. And then we want to decide where the decimal will end up. And it will always end up right after the first non-zero digit. Okay? And then we're going to move the decimal point as many places as we need. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So that becomes our exponent. So this is 2.5 times 10 to the 9th. Okay, let's do another one. The exponent is the number of the places that we moved. Okay, so here we have 1.000579. Here we're going to have to go the opposite way. We want to decide where the decimal point will go. So we're going to move it from the left to right, and we're going to count again. 1, 2, 3, 4. We always want it after the first non-zero digit. 3, 4, 5. So we need to move it 5 places, and we rewrite it. But because we're going left, we've got to make this a negative exponent. It's 5.79 times 10 to the minus 5. Okay, so we're starting with something less than 1. We're going to have a negative exponent. Okay, now there's some rules about how to perform calculations in scientific notation. And the one that's actually the more difficult is addition and subtraction. Okay, so we express our numbers using this format. This number is between 1 and 10, right? This number is an integer. So let's say we had 4 times 10 to the 6th plus 3 times 10 to the 6th. As long as our exponents are the same, we can just add those coefficients. So it's just going to be 7 times 10 to the 6th. Same holds true for subtraction. If I subtract, as long as my exponents are the same, they're both 6 here, I can just subtract. So it's going to be 1 times 10 to the 6th. Looks pretty easy, right? Gets a little more complicated here, because I do not have the same exponent on both of these. So what I have to do is make one of those exponents, change it to make it the same as the other. And it's usually easier to change the smaller one. Okay, move the decimal on the smaller number. So I'm going to move it 1 place to the left. And when I do that, it becomes 10 to the 6th, but the decimal place has moved, and now I can add these. I've got my exponents the same, and I can add 4.3 times 10 to the 6th. So try this one. Okay, I've got to make the exponent the same. Try it before I show it. Okay, so what I'm going to do here is take the smaller coefficient and move it, and I get 0.0237, and now I can add them. Okay?